Let us begin by reviewing some definitions relevant to control systems. Most control systems are shown in this configuration where the variable you're trying to control is designated by the letter C. This is standard notation. C is a controlled variable. We show a block here, we'll call this H, which represents the transfer function. Typically this is a transducer like a tachometer or a resolver where we're measuring the controlled variable, which very often could be position or velocity, and then we feed back a signal, which could be a voltage, to some point where we will compare it with some reference or input signal. We'll call that R. Now the difference between the fed back signal and the reference we'll call an error signal. This is very similar to what you have in a thermostat where you set the room temperature, say, to be 70 degrees, but it's only measured to be 68 degrees, and so the 2-degree difference is the error, and that will cause something to happen which will cause C to adjust itself so that eventually this device tries to null itself out. In the forward loop, we'll define a transfer function G and simply call it the forward loop transfer function. So the only other symbol that we very often will use is a B to indicate a feedback signal at this point. Now some simple algebra with some very important algebra is about to follow. We can write that the error signal E, now everything we're looking at here is a function of S, Laplace transform. E is equal to the difference between R and B, R minus B. However, B is equal to the product of C multiplied by transfer function H. So E is also defined as being equal to the ratio of C divided by G, because you can see that G times Z gives you C. So if I were to equate these two to each other, I have that C over G is equal to R minus CH. Let's multiply both sides by G. I get that C is equal to GR minus G times C times H. And let's put all the C's together and all the R's together. Bringing this GCH over on the left-hand side, I have C times 1, that's this C in here, plus GH, when I bring that over, that's equal to G times R. And now I can find a ratio of C over R and write it this way, that C over R, based on this last equation, is G over 1 plus GH. That's what we're looking for. This is the closed loop transfer function, and it shows you the role of G and H in controlling the ratio of C to R. Remember now, everything here is in terms of Laplace transforms. This is called the closed loop transfer function. We will have need to use one other transfer function, which I'll put in a block down here, and it will be called the error transfer function, E over R. That's easy to write because since C is equal to G times E, if I divide both sides here by G, I get 1 over 1 plus GH. And that's the error transfer function. R is the input.